Hi guys, welcome to Science in 5. In this video we're going to focus on grade 12 maths revision, and we're focusing on trigonometry. Okay, we're focusing on trigonometry. So the purpose of this video is just to prepare you for your maths, especially with the trig section, to show you how to attempt some of those questions. Okay. Without using a calculator, write the following expressions in terms of the sine of 11 degrees. So we are going to use the sine of 11 degrees as a reference. Sine of 191. Now, sine of 191, how can I use this in terms of sine 11? Well, I know that I can write this as sine of 180 degrees plus 11 degrees. Okay, so this angle sine of 180 plus 11 degrees, I can find it in which quadrant? It's going to be in this quadrant. In this quadrant, only the tan ratio is positive. So this means that this angle is actually negative. So we can reduce this to the negative sine 11 degrees. Okay. Now the cos of 22 degrees using the sine of 11, well, I can see that 11 plus 11 is 22. So that's cos of 11 degrees plus 11 degrees. Now we know that the double angle formula, cos of 2 theta, how can I write this in terms of sine of theta? Because I want to be able to use the sine of 11. This is the same as 1 minus 2 sine squared theta. Notice there we've got 2 of theta. Here we end up with just theta. Okay, so this is the same as 1 minus 2 sine squared 11 degrees. Okay, that's it. Now, one point 1.3, we're asked to simplify to a single trigonometric ratio. So we are asked to simplify to a single trigonometric ratio. Okay, so let's focus on that question. Okay, now the cos of x minus 180 degrees, where is that angle going to be? Well, again, using my diagram, I know that C, A, S, T, the cast diagram, 0 degrees. Positive angles of theta, anti-clockwise. Negative angles of theta, clockwise. So the cos of x minus 180 is the same as minus 180 degrees plus x. So if I go minus 180 degrees, I will come to this quadrant here, because minus 180 means you go to this line, and then add x, you come back to this quadrant where cos is negative. So this becomes negative cos x. So 1.2, I've got negative cos of x plus root 2 times, so this is a single ratio and being multiplied by the root 2. So the root 2 stays there. And then I now need to expand that using my sine formula, compound angle. So for sine, I know that it's sine, cos, cos, sine. So this becomes the sine of x, the cos of 45, plus the cos of x sine of, let's remove that, sine of 45. Okay. Now, my negative cos x remains plus root 2, open bracket. Cos 45 is a special angle. Sine 45 is a special angle. Cos 45 is the same as 1 over root 2 times the sine of x plus the same 1 over root 2 times the cos of x. Okay. Now, I can multiply out, distribute the root 2. I can see that 1 over root 2 times root 2 gives me 1. So this now becomes negative cos x plus the sine of x plus another cos of x. The negative cos x and the positive cos x cancel out. I remain with the cos of x. So that one is done. 1.2 is done. Now 1.3 is quite interesting because it says I'm given a whole lot of information there. I'm given sine p plus sine q equals 7 over 5 and p plus q equals 90 degrees. So this idea of 90 degrees gives me a clue as to the idea that co-functions, we can swap between the sine and the cos. I can swap between the sine and the cos. Okay? What do I mean? Well, for example, sine of p, so I can see that p is actually equal to 90 degrees minus q, right? Angle p will be equal to 90 degrees minus q. Therefore, if I was to say the sine of p is the same as the sine of 90 degrees minus q. So this now, I can quickly change this to what? The cos of q. So the sine of p, I can see that it's the cos of q. The sine of q can be the cos of p. Will that information be necessary? Let's see. Now they say I must find the value of sine 2p. Okay. So sine of 2p, double angle for sine, this becomes 2 sine p cos of p. Now, I want the value of, I don't want an expression, I want the value of this. Okay, and the only ratio that seems to give me a value is this ratio here. But here I can see there is a sine p, but I don't have a sine q. How can I get a sine q? Well, we know that the cos of p will be the same as the sine of q, because these are complementary angles. Okay, if you look at it, the cos of p, okay, if I remove the sine here and I say the cos of p will be the cos of 90 minus q, which now becomes the sine of q. So I can now say this is the same as 2 sine p sine q. Now I've got a sine p and a sine q. So I can see that, okay, I've got sine p and sine q. Okay, now how does that help me? Well, if I look at the ratio, I've got sine p plus sine q equals 7 over 5. How do I get 2 sine p sine q from that? Well, if I square both sides there, it should work. Okay, so what I'm going to do is I'm going to say I've got sine of p plus sine of q is equal to 7 over 5. Is that it? Yes. So if I square both sides, I'm going to get sine squared p plus the middle term, sine p times sine q is sine pq. Then you multiply by 2 becomes 2 sine p sine of q. The last term becomes plus sine squared q is equal to, we square the top number, 49, square the bottom number, 25. So now I can see that, oh, I've made a great stride there. There is a 2 sine p sine q. Here I've also got a 2 sine p sine q. So I've made an important stride. Okay, that's fine. But now, what can I do? Well, sine squared p and sine squared q, I can get rid of that because I know that sine squared p or sine p, we've just shown that sine p is the same as cos of q, or sine q rather is the same as cos of p. So where there's sine q, we can put cos p. So this becomes cos squared p. So now I can say sine squared p plus cos squared p plus 2 sine p sine q is equal to 49 over 25. This, using the Pythagorean identity, this becomes 1. Okay, so now the 1, in fact I should put my green line to include that, okay, including the p. So 1 plus 2 sine p sine q is equal to 49 over 25. Subtract 1 from both sides. 2 sine p sine q is equal to 49 over 25 minus 25 over 25. Okay, so when you're subtracting 1, it's going to be 49 over 25. 1 is the same as 25 over 25. 49 minus 25 is 24 over 25. So this becomes 24 over 25. So sine 2p the sine of 2p, the sine of 2p is equal to 24 over 25.